All right, welcome back. We're about to start our new unit of quadratics. And before we can get right into quadratics, let's review some of our basic algebra skills that you've picked up throughout the years prior. And now we're going to put it all together. I'm going to put them to good use in this unit. So some of this will definitely be review, which is good, and some of it might be actually brand new, and that's okay too. So just listen up. I'm going to go through it step by step. This is a very short lesson with just a few examples here to get you thinking again. So we're first being asked to expand and simplify. So when you're being asked to expand and simplify, you're looking to see what's directly in front of a bracket. So in this case, we have a bracket that has two things in it, negative 3x and a plus 6. That's called a binomial because there's two parts to it, two terms. There's a number 2 in the front, and the number 2 is going to go, and it's going to meet up first with the negative 3x. And when they meet up, that's multiplication that's going to happen. In the order we do it in matters. So we think in our heads we have to. So the order we apply this is what is the sign going to be? What is the number going to be? And then any letters. Okay, signs, numbers, letters in that order. So we put an equal sign down. A positive times a negative, right? A positive meeting up with a negative. Those are opposites. So we know we're going to end up with a negative. So I just did the sign. Then we're going to do the numbers. A 2 times a 3 is a 6. Any letters? Yeah, there was an X here. The X comes along for the ride. Now the 2 is also going to meet up with the positive 6. So we start the process again. A positive times a positive is a positive. A 2 times a 6 is a 12. Now notice the minus 7 is not inside the bracket, so he doesn't get multiplied with the 2. So he just gets written down. He's just brought down at the back. Now we collect like terms. Those are like terms, right? They're constants. They're just plain numbers, no letters attached to them. So they might as well go together. So the negative 6x has nobody to go with, so we just copy him down again. But 12 subtract 7, right? When you have 12 and you take away 7, that's going to leave you with positive 5. So that's what we finish with as our final simplified answer, because you can't combine these two guys because they're not like terms, right? One has an x, one doesn't. So they stay separate. So let's move to the second one. The second one is exactly the same as the first one, except it's longer. So directly in front of this first bracket, we have a 2. The 2 is going to meet the 4x squared, then the 2 is going to meet the 3x, then the 2 is going to meet the 1. So again, we do our order, signs, numbers, letters. Positive times positive is positive. So I don't have to write down a plus sign because it's the first one in line. So it's understood to be positive unless you see otherwise. 2 times a 4 is an 8, and we just carry down the x squared. Repeat. Positive times positive is positive. 2 times 3 is 6, and the x comes along. Repeat. Positive times positive is positive. 2 times 1 is 2. No letters. Then we move to the next grouping. The next grouping is a bracket with a negative 2x, so the negative travels with the 2 and the x to meet up with the 8x and the negative 3. So a negative times a positive is a negative, a 2 times an 8 is a 16, and x times x is x to the power of 2. So remember, x to the 1 times x to the 1 is equal to the x to the 1 plus 1. We keep the base and we add those exponents, which gives us the x squared that we got here. Repeat again, negative times negative is positive, 2 times 3 is 6, and the x came along for the ride. So now you look at this string of terms, right, this polynomial, and you see if there's anybody that can go with anybody else. So I'm going to underline the ones that go together. So here's some x squareds, here's some x squareds, right? So we're grouping them based on having the same letter with the same exponent on those letters. Here we have 8 of them, and then we subtract 16 of the same thing. So altogether we have negative 8 of those things. Those things happen to be x squared, right? It doesn't change to x to the 4 all of a sudden. We were grouping x squareds. Next, we have x's. So we have positive 6x, positive 6x. So plus 6 gives me plus 12 of those things. It doesn't become x squared. It's just x's. And then, so done, 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 done. The last thing is just plus 2. Don't forget to copy down any terms that didn't have anybody to go with. And we always like to write our terms from highest exponent to no letters, so no variables, meaning the constant goes at the back. That's just the order we like to see them in. It's not wrong if you write it in a different order. It's still the same amount, but it just doesn't look right. All right, now in the third one, we have an x times an x, and again, they match. So we have like, but we're not adding here. We are multiplying. So now we're going to add the exponents together. And 5 plus 7 gives us 12. Now, you didn't have to write the 5 plus 7 step, but I just wanted to show you where the 12 comes from. Okay, so you keep the base and you add those exponents. Here, in this one, again, number goes with number, goes with number. Letter goes with letter, goes with letter. So the number part, 7 times negative 3 is negative 21. And then in your calculator, go negative 21 times 5, and you get negative 105. X squared times x to the 4 times x. Now, if you don't see a number there, you know it's an exponent of 1 automatically. So 2 plus 4 plus 1. So again, you didn't have to write out this step, but I'm just showing you very clearly where my exponent comes from. 6, 7, total of 7. So we just combined them and we got 7 x's all together. Same thing in this last one over here, because we have to clean up the top, numbers with numbers, letters with letters, y's match with y's, and we're going to add the exponent on the y's. The 3 and the 2 get added together. So that gives me 4 times 3 on top, which is 12, y to the power of 3, 4, 5. And then on the bottom, we just copy down what was there. But now we put number divided by number, y divided by y. And when you have the same base and you are you're dividing, remember that you keep the base and you subtract the exponents. Top exponent minus whatever the bottom exponent happens to be. So 12 divided by 2 is 6. 5 minus 3. So again, I'm showing all my work here. You could just write down the answer. 5 minus 3 is 2. So most of you would just write down that step, and you wouldn't even bother showing the subtraction. So that's it for that area. So it was a review of your exponent laws and a little bit of your distribution. So now let's go down to something that you may have done in elementary school, which is algae tiles. Those are those little tiles that are white and red, and they're in different shapes. Some are squares, some are rectangles, and some are like little tinier squares. If you happen to see it white side up, then they're +1, so it's positives. If you see them the shaded, then it means that they're the negative version. So those single little guys are the single constants, right? Just the numbers. And then the x squareds, so it says sketch algae tiles. So x squareds are the big squares. That's what those are. So it means you have 2 big squares. So I'm going to do my best here trying to make squares. Yeah, not very good. But anyway, those are x squareds. Why? Because this side is worth x, this side is worth x. So the area is x times x, which is x squared. And I have 2 of them, right? So this is also an x squared. So I have 2x squareds. Negative 3x's. Okay, what's an x? An x is the same length as one of these sides of the square. So we can make them like this. And I have 3 of them. But not only do I have 3 of them, and again, why are these x's? Because this is worth x, this has the length of 1, x times 1 is x. So here's an x, here's an x, here's an x, right? X times 1 is x. So x, 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 3x. But they're negative. And if you remember, negatives happen to be dark. So I'm just going to kind of shade them in like this to give the impression that they're dark. So I have positive 2x squared, negative 3x's, positive 3. Well, that's just easy. So again, you see how small this little length is? That's 1. So 1 times 1, 1 times 1, 1 times 1, 1, 2, 3. Right? That's 1, that's 1, that's 1. So here's 2x squared, negative 3x, positive 3. Okay, so maybe you did this in elementary, maybe you didn't. It's not really that important in the grand scheme of things. We don't actually use these in high school, but it does help some people visualize what is it that we're talking about here. So in this case, we don't have any x squared, so we don't have any big squares, but we have a couple of those smaller rectangles. This time we have 2 of them, and because of the negative sign, I know that they've been colored in. So this is negative 2 x's. Negative 4 means 4 of the little single tiles, but again, negative means they're colored in too. And that's minus 4. Okay, so now we're going to go the opposite way. So here's the picture. You have to write down underneath now what each of these things, you have to write down underneath what each of these is representing. So plus, right, because it's white, plus 1x squared. So that's what that is. You can put the 1 if you want in front, but you don't have to. This would be negative 2 x's, and this would also be negative 1. So there's your trinomial represented by those algae tiles. Here, 1, 2, 3, 3x squared that happen to be negative. Here's an x, here's an x. So we have, and they're white, so it's positive 2 x's, positive 2 single numbers there, 2 single constants. All right, so that's just to get you thinking again how we were using algebra in the past. This is going to come up later on in this unit.